Good day and welcome to our second episode of the Microbially Speaking podcast. I'm your host, Kevin, and thank you so much for joining today. I'd originally not intended to release an episode this week, and I am in fact partway through the process of editing a script for an episode that we're still intend to release next week. But over the past couple of days, I've had a lot of colleagues, a lot of friends reach out with questions about the current situation that's happening with hantavirus on the cruise ship, the MV Hondius. And so we're going to do a little bit of a bonus episode today. We're going to take some time to unpack that situation and really try to answer the question that seems to be on everyone's mind. Is hantavirus the next COVID-19? Now, before we dive into that, let's first ask the question, what exactly is hantavirus? And actually, hantavirus is not a single pathogen, but it's instead a family of viruses collectively known as the Hantaviridae. This is about 7 distinct genuses of viruses and over 50 recognized species. So this is a large family of viruses. They're all enveloped RNA viruses, so structurally they're very similar to respiratory viruses that we know and love, like influenza and RSV and even coronaviruses. And that fact does become important later on, so keep that one in mind. We'll remind that when we come up to why that's important. Now, I find that taxonomy is always a little loose when it comes to virus naming conventions, specifically how we call viral species names. But we can broadly identify at least 8 major hantavirus species which are relevant to human health, all of which belong to a genus known as the hantaviruses. Now, we further group these 8 viruses that we care about as humans into 2 distinct groups, the old world hantaviruses and the new world hantaviruses. And they're typically associated with 2 very distinct clinical presentations when they cause infections in humans. Broadly speaking, our old world hantaviruses are found primarily in Europe, in Asia, and in Africa, and they're associated with a syndrome called hemorrhagic fever with renal syndrome. What this causes in people is you end up with thrombocytopenia, so decreased platelets, with small bleeds all through the body. You end up with low blood pressure, and then the renal syndrome, you end up with kidney failure or renal failure. Now, New World hantaviruses found in the Americas are associated with an illness called hantavirus pulmonary syndrome, or sometimes hantavirus cardiopulmonary syndrome. And this one has less of that hemorrhagic fever feel, less of that renal impact, and instead we get all of our disease, all of our illness in the lungs. We get significant pleural effusion, so fluid building up into the tissues of the lungs. Now, despite our aversion to the term hemorrhagic fever, our New World hantaviruses and that cardiopulmonary syndrome actually has far worse clinical outcomes compared with our old world hantaviruses. Hantaviruses are host adapted to rodents, where they cause a silent or an asymptomatic infection. In their typical host, a hantavirus will invade through tissues of the upper respiratory tract, replicate initially in those tissues and in the lungs before eventually spreading through blood to infect other tissues throughout the animal. The virus is shed in urine, it's shed in feces, shed in saliva, and it passes into the environment where it contaminates surfaces and relies on close proximity to other animals to allow transmission and propagation of the virus. Now, as I said, this is a silent infection, so infected animals really don't show evidence of infection. What's also interesting is that hantaviruses can establish a persistent infection where a rodent can't clear the disease, can't clear the virus, and is just chronically infected, shedding the virus at low levels or intermittently. Now, this is all part of a carefully choreographed balance between the virus replicating and the rodent's or the animal's immune system. And this carefully balanced dance is really key to another unique feature of hantaviruses, is that their host range is extremely narrow. They survive and replicate asymptomatically and persistently in one single host rodent species. So each virus has one rodent that is its main host. Now, other rodents and other animals can become infected, But these are what we would call a dead-end host. Not that the host becomes dead, but that the virus can't effectively replicate and transmit. And so the virus is at the end or the dead end of its replication cycle. Now, this is often where humans come into the equation. For those 8 hantaviruses that are clinically relevant to humans, we exist to them as dead-end hosts. Our exposure often occurs when urine, feces, or saliva from an infected animal dries in the environment and is subsequently inhaled by a person. So I want you to imagine that next time you're crawling up and sweeping out mouse droppings from a crawl space, all the while you're aerosolizing all of that virus that's constantly being shed out of rodents. Now, remember what we said earlier. Hantaviruses are enveloped RNA viruses, which means they're somewhat fragile and not really stable in the environment, especially for long periods of time. That outer membrane, or that envelope as we call it, is highly susceptible to drying out. And once it becomes destabilized, the virus is essentially inert. It can't infect anyone else. So outside of the host, these viruses will only survive for between a few days and a few weeks, depending on how protected they are. This is where that state of persistent asymptomatic infection and that fine, balanced coexistence with their rodent host becomes essential for viral replication. It relies on that persistent shedding into the environment and the fact that rodents live in very dense populations to compensate for the environmental instability of the virus. And that way it's always ensuring that viral propagation can continue. Now, when humans are lucky enough to become infected, it invades us much the same way that it invades rodents and much the same way that regular respiratory viruses that we encounter every year invade us. It enters into our respiratory epithelial cells. But unlike rodents, we don't experience that same asymptomatic and silent infection. Humans undergo an incubation period lasting somewhere around 2 to 3 weeks on average, but sometimes lasting as long as 6 weeks, and then eventually enter into a very nonspecific flu-like illness or prodromal phase with fevers, myalgias, and general malaise. As the virus replicates and invades different tissues, it infects the endothelial cell lining of our blood vessels. That infection and the body's immune response causes something that we call a capillary leak syndrome, where all of our blood vessels become damaged and the fluid leaks out of the blood vessels and into the surrounding tissues. This is what manifests as hemorrhagic fever with renal syndrome in those old world hantaviruses, or hantavirus cardiopulmonary syndrome in new world hantaviruses. The key difference in the clinical presentation is likely driven, at least in part, by altered tissue tropism of the specific viruses, meaning alterations in which tissues the viruses can readily or more preferentially invade in people. Regardless of the clinical manifestation, though, the capillary leak syndrome, that leaking of capillaries, is what drives the mechanism of disease. Now, with humans acting as a dead-end host, we tend to not see any human-to-human transmission, but there is one notable exception: the Andes virus. The natural reservoir for this virus is the long-tailed pygmy rice rat, which is native to South America, primarily in Chile and Argentina. The Andes virus is the only hantavirus which has been shown to have potential for human-to-human spread, though the specific reasons still are not quite well understood. One leading hypothesis is that this virus seems to have better tropism for the salivary glands and upper respiratory tissues, allowing for more efficient exit from the host, and there's more efficient ability to transmit to another person. Now then, how does this all intersect with what we're currently seeing on the cruise ship, the MV Hondius? Well, that cluster has been confirmed to be the Andes virus. And at the time of this writing, there have been 9 linked cases to that outbreak, 7 of which are lab confirmed and 2 probable cases, including 3 deaths. It's all thought to have started back on April 1, when the index case boarded the MV Hondius in Argentina. This individual had been traveling extensively through South America for the past 3 months, boarded the ship on April 1, developed symptoms on April 6, and died on April 11th. Now, the case history is really important here because what it suggests is that this patient likely acquired the infection while traveling in South America, was incubating the virus when he boarded the ship, and subsequently developed symptoms while at sea. Now, the person he was traveling with also developed symptoms and died. However, their symptoms started on the 24th of April, 18 days after the index case first showed signs of infection. This timeline is very much in keeping with the average incubation period of 2 to 3 weeks, and so it is suggestive of secondary transmission, though in fairness they could just as easily have been exposed at the same time pre-boarding and just had a longer incubation period. Additional cases start to pop up on board the ship between the 24th and the 30th of April, representing cases 3 to 8, and these really support that idea of secondary transmission on board the ship. Each of these cases is within that expected time frame of 2 to 3 weeks incubation. And so it really supports the idea of one index case importing it and transmitting it to others on board. The most recent case, our 9th case, showed a symptom onset on the 10th of May, which is around 4 to 5 weeks out from the index case and only around 1 week out from disease onset from all of the secondary cases. This one's a little bit harder to place. As a reminder, hantavirus can incubate for up to 6 weeks, and so this case could represent secondary transmission from that index, just with the longer incubation, or it could represent a third generation of transmission, but with a very short incubation. Now, it is, of course, important to note that when we talk about this epidemiological situation, this is a rapidly evolving situation, and we're certainly going to learn more in the coming weeks that might change this picture. This is the task of the World Health Organization, the European CDC, and other global health agencies, is really unpacking what exactly happened on board the ship and follow the path of the virus. So where does this all leave us then? Is hantavirus going to be the next COVID-19? Probably not. And it's not because the disease is mild, because obviously it is not, but the transmission dynamics are completely different. It's important to note that this is not the first time we've seen clusters of the Andes virus, and it's also not the first time we've seen human-to-human spread. Most of the time, clusters or outbreaks are associated with direct household contacts in South America or with healthcare workers providing care without adequate or appropriate PPE. In other words, it's associated with those who have close and prolonged periods of contact. Andes virus is far less infectious than COVID-19 or other respiratory viral infections, and the World Health Organization does not consider it a virus of pandemic potential. With that said, though, rapid case identification and contact management remains a really important hallmark and a really important step in halting multi-generational transmission because protracted transmission can still occur. Between November 2018 and February 2019 in Argentina, there was a large outbreak resulting in 34 cases across 4 generations of virus spread, at least 4 generations of virus spread. This was all driven by infectious individuals attending large social gatherings whilst sick, demonstrating that you can see transmission outside of household contacts and into more of a social setting as a possibility. What that event also demonstrates is that implementation of contact tracing and quarantine were highly effective in interrupting transmission and ending the outbreak. And so using that same model here is certainly an effective strategy in making sure that we don't see ongoing and continuous spread of this virus outside of the clusters associated with the cruise ship. What's really unique about the situation on the MV Hondius is the fact that it's a multinational outbreak, since the ship involves passengers and crew from 23 different countries. Some cases or some passengers have already debarked the ship and returned home, potentially exposing others outside of the ship or on flights. Now, cruise ships are also a really strange epidemiological environment. You share this indoor space with people and have frequent, repeated interactions with really what amounts to a relatively small cohort of individuals. It creates the perfect storm for really rapid spread of pathogens that don't like to easily transmit person to person in other settings. And it's not unlike kids in a daycare in that sense. You see things transmitting that you really don't expect to transmit outside of household settings. However, in a post-COVID era, with we still have public health infrastructures that's readily primed to react and mobilize to new epidemic or pandemic threats, we appear to have been able to really mount a global response rapidly to support contact tracing of exposures both on and off the ship. The biggest challenge we have to contend with now is that extended incubation period, with potential for secondary cases to convert as far as 6 weeks post-exposure. It's certainly a possibility that we see more cases before this outbreak is officially declared over. Now, what if we get cases in North America? Could the virus establish itself here? And again, I'll say probably not. The natural reservoir for the Andes virus, after all, is the long-tailed pygmy rice rat, and that is not native to North America. All the Andes virus has to contend with up here are dead-end hosts, which cannot support sustained ongoing transmission. Now, unlike many respiratory viruses, which are zoonotic and have a wide range of hosts, hantaviruses are uniquely adapted for one preferential species to infect. It wants one host rodent and doesn't like surviving in others, and really doesn't have much selective pressure or need to adapt to other hosts. This means that the Andes virus probably would not have a good likelihood of establishing itself in North American rodent species or in the human population. Now remember, we do have our own hantavirus in North America, the sin nombre virus, which infects deer mice. But it's important to note that these are not separate strains of the same virus, but entirely separate species of virus. So even the idea of genetic reassortment or somehow adapting and co-evolving with each other to better establish itself in a North American mouse population is highly unlikely. So with all this in mind, how exactly do we manage this? The name of the game here is case and contact management. Continuing a global effort to track and quarantine exposed individuals for the duration of their 6-week incubation period is really what's crucial to halting any further transmission. Beyond that, infected cases are largely just treated with supportive care. From an infection control lens, many public health agencies are now recommending that the Andes virus should be managed under airborne droplet contact precautions with an N95 respirator, eye protection, gown, and gloves, and the patient placed in a negative pressure isolation room. Now that doesn't apply for other hantaviruses. Other hantaviruses like the sin nombre virus in North America do not have that potential for person-to-person spread, and so no isolation or additional precautions are required. That said, you might want to throw a mask on next time you're sweeping mouse droppings out of your shed. And with that, this brings us to a close on this week's episode. If you have any questions on hantavirus, or if there's any other topics in microbiology you want to learn about, leave a comment below. If you enjoyed the video, please hit the like button and consider subscribing to the channel. Thank you all so much for listening, and we'll see you next week on another episode of Microbially Speaking.